6 when we started testing this. He's now 7. So we've been talking about this for a number of years. This is from an effort I did when I was in University of Bergen some years ago in the late 1990s. And we were then developing interactive simulations and using an underlying mathematical modeling system called system dynamics and trying to figure out how we could promote learning. And we had a visit by Dave Merrill, came to visit us in Bergen, and he said, these simulation learning environments are really beautiful. They look great. How do you know people are learning anything? And it was really a startling question because we had spent all of our time on developing, and so then we had to figure out, well, how are we going to test it, and also how are we going to implement this over time? So we started thinking more seriously about things that instructional designers typically think about. So then when we did that, we decided we developed this sequence of increasing complexity. So first you use the simulation environment to develop some familiarity with the context in which people are exploring within the simulation. So it's kind of an exploratory thing. Even though it's running in full time, they can stop it, they can ask questions, you can point things out. So then you present an anomaly in the simulation. So suddenly the behavior of the simulation changes, and the person that's engaged with the simulation is presented with the challenge, how do I explain this anomaly, or how do I bring the system back into balance? So that's a level up. So this was sort of the history of how I was doing with simulations, and then we had an assessment methodology for this that I'm not going to go into. So we had some principles, we had some instructional design, sequence of things. You don't just give them the simulation, you stage it so they gradually develop competency over time. So this was with master level students at the University of Bergen. So that was the framework we had, and it got published a few years after we developed it. So that's where the journey began. And then I started thinking about problems in this country, and I had been doing some work at other universities and listening to other researchers talk about what's going wrong. How come American students aren't performing well, and especially in the area of mathematics? So all the research was showing where American students drop behind the rest of the world was about the 8th grade level when they teach algebra. So I had an experience in a rural multi-grade school in Indonesia that I observed math in that, and it was a 5th grade math, a 5th and 6th grade math group, 2 grades together. And the 5th graders were working on a math problem. It was a geometry problem, and the problem they were that they had to solve was finding the perimeter of a polygon that was formed from a rectangle and a right triangle. In order to solve that problem, these 5th graders in this rural school in Indonesia needed to know the Pythagorean theorem. This is 5th graders in a rural school in Indonesia that you had to walk 2 miles from where you left your car to get to the school. So I didn't believe that this was possible, but they actually were doing this. And so then I thought, okay, well, kids can do better than they, other places would. And the instructor had 2 years of college training, didn't have a full degree. Yeah, so anyway, so that got me thinking about, well, there's a developmental aspect here that we're ignoring in this country and in our schools. So I started to think, well, how do we develop these higher level problem solving skills? And so I did some research, KK's done some research, Dr. Lung has done some research. We looked at a lot of models for developing higher order reasoning, critical thinking skills. And so this 9 phases are basically a consolidation of what I found from the existing literature on critical thinking. And my idea was we take a developmental approach. All of the examples I found, and I think all the ones that they also found, were in there would be one lesson or one course or one domain. They never cut across domains, and they really didn't start very early. So you can't learn to be a critical thinker in one course or even 1 year was my notion. This takes time to develop. So I thought, well, if we really take that seriously, how do we develop these skills? So it turns out, I thought, well, we start by working on the early phase would be the couple first things here. We develop a mindset for asking questions. We get the kid to ask questions. We present them with unusual things. And what we do not do is we never tell the kid that's wrong. You don't need to do that if you want to encourage asking questions. You can say, well, that's interesting, what about this other thing? You can just redirect. You never have to say that's the wrong answer. And you'll see some examples of that. The middle part is based on my own background in logic. So we need to develop these logical skills. Used to be, when I went through school, we got logic when we learned geometry because we had proofs, basically. And I loved it, but it's no longer even required. And when they teach geometry, anybody know the math curriculum now? Are they teaching proof procedures in geometry? I didn't think so.
They are less now. Compared when I was also a student, there are so many proofs, but now they are reducing it. I don't know why.
So that's been lost. And there was a philosopher called Matthew Lipman who created a book to teach logic at the at the 8th grade level. The book was called Harry Stottlemyre. It's available for free on the internet now because this was in the 1980s. I'm older than dirt. But anyway, so I had that book. I came across that book a long time ago, so I thought the idea was good. All the examples were the kinds of things a child would encounter in their classroom. And they had to go through a logical, Harry Stottlemyre is a play on the name Aristotle. So it was all about syllogisms. And so working out which reasoning patterns were valid and which weren't. But we don't teach that. We don't even teach it at the college level now. So I get students who come in, my doctoral students, don't know logic. They don't know what a valid argument is. And so I think that's the missing piece in the middle. So that's, and at the very end, it's sort of so there's a setup phase, there's a primary learning phase for teaching critical thinking, and then there's this sort of refinement resolution phase at the end, reflecting about the process. And I call this the 5 C's. So the 21st century skills you've probably heard are communication, collaboration, creativity, critical thinking. And so the 5th C in my mind is contemplation, metacognition, reflecting back over the process and thinking, becoming aware, self-aware. That's why I asked Mark the question about awareness. Yeah, where does that come from? Where does this consciousness come from? But we maybe, hopefully, can teach that. Hopefully, we'll find out. So these are the 9 phases, and then what NetDragon has asked me to do was in every one of these phases, tell us the specific skills that count as mastery of that phase before we let the kids go to the next phase. So we've made an attempt, and right now we're focusing on the inquiry phase, developing a mindset for asking questions, noticing things that are unusual. I have to give KK credit for that. My early example, you'll see in a minute, what KK said was, you're really testing observation skills. Or can you notice something unusual? Or does the child notice something unusual? It never occurred to me to use that word, but you get credit for that, KK. Yeah. So, but developing, looking at things that are unusual and then asking questions about things that are unusual. The other part of this is, I thought that the experience I had with Jonah and Noah was with Google Home, or the Google Assistant. You can ask questions for Google, and one day Jonah and I were having a conversation, and Jonah came across something he didn't know the answer to, so he said, hey Google, what about, ask a question. 6-year-old Noah is in the room watching this happen, and then later Jonah and I were talking, I'm drinking a beer, he's drinking tea or something, and so I asked Google a question, so I figured, oh, okay, this is an interesting device, and I couldn't, but I knew Google knew, and then the next day I'm babysitting Noah, and we're talking about something, I don't remember what it was, and Noah asked Google a question, and so now he does it all the time, right? Yeah. So not only that, later, because they like me as a babysitter, they bought me a Google Home device. So I have Google in my house too. So Jonah and I again are talking, and we asked Google a question, and Google said, I'm sorry, I'm not able to answer that. And we say, nonsense. We know she knows the answer. We haven't asked the question the right way. So Jonah and I reformulate the question, and I think the 3rd time around, we found a way to ask it that Google gave the answer. Noah, who's now 7 years old when this happened, starts doing the same thing. He doesn't give up when he doesn't get an answer. He reformulates the question. So graphical language interface, natural language interface, conversational interface is that's why we have Rodney working on this project. That's why I'm interested in a conversational interface, because it seems to resonate with the user. They get responses back. Anyway, that was a side trip. So this is sort of a quick look at the game. So we're looking at developing specific competencies you saw before, and also trying to develop some habits of thinking. And so trying to save your friend was the game environment that you saw earlier. So I thought I could even simplify that, because kids like to play a game called hide and seek. They go somewhere and hide. So to find where your sibling or friend is hiding, you have to answer some questions, and there'll be multiple of these examples. Another thing we thought about was teachers using this. So this came up yesterday. So if you don't give teachers a tool they can expand themselves, they're not going to, they want to own the tool. They want to put in their own examples. So this will be developed by NetDragon with some initial examples, but it'll be a template so teachers can add their own examples. They already do this with their 101 project. So that won't be new to NetDragon. So they seem to like this idea. So this just tells you we're looking for a friend. The examples I gave to DJ when last time I was in China was, he liked the logic examples. So finding among a collection of statements, which of these cannot be true? And so I'm used to that in logic from paradoxes. And so that's kind of a finding the unusual thing. That's from a game called Where's Waldo? Have you seen that? The book Where's Waldo? So there's a page with like 1,000 images on it. One of those is an image of Waldo. And so the child has to look through the page and find Waldo. So I thought, well, we'll do that. We'll find the contradiction. Here's, 100 statements. Find the one that can't be true. But we haven't given the script for that. So early on, this is one of the early examples. This is the script that I've given. Script is not a good name, I know, for this, but this is what NetDragon has. So part of this is trying to find out what the kid is interested in. So there'll be 7 of these ordinary rocks is the initial example. And so the system just asks the kid, which of these rocks do you think is unusual? This is the observation skill. And there's no wrong answer. The kid can pick any rock they like. So let's suppose they pick the one on the far left, the one that we might think of as ordinary. Then the system will ask, what did you think was unusual about that rock? Any answer is okay. So now we're find a kid to describe something, they say something, then the system can push them towards one of the other 3 rocks. And those are picked for a reason. So they might pick the geode in the middle, and then the kid will give some descriptive answer, probably color or something, the crystals in the middle, whatever, what they saw was unusual. And then we try and prompt them for, where do you think that rock came from, or how was it formed, because it's different than the others. And then later examples, as they go through the game, there could be things on volcanoes. Right, this is happening in Hawaii now. So there'll be a lot of geodes available there. The second one is the one that is I don't know if you can make out the image, but it's a fossil embedded in a rock. And so then ask what's unusual about that, and I say, well, there's something weird in the middle of the rock, whatever the kid says is okay. The system can say, well, that's actually the fossil of a sea creature. How do you suppose it got there? Kid may or may not have an answer. The system can give information. And then as the kid progresses, these examples can recur later at a higher level. The system will say, well, that fossil was found at 8,000 feet above sea level, which is true. This came from the Canadian Rockies as part of the Burgess Shale, which was found by a Canadian paleontologist. And there's all kinds of fossils there. So then the system wants the kid to know that how did a sea creature manage to get 8,000 feet above sea level? So now the kid has to go look for explanations. Where do these sea creatures live? And it turns out it can't be found anywhere today. So what happened to the sea creatures? So these examples can take a kid to a thought along the way. So I think this repeats everything I've said. The idea is to embrace a developmental process, go through stages, and there will be some kind of reward system for progressing from one stage to another. It will be more than badges. I don't know what NetDragon will come up for the reward for going from one level to another level. I propose a number of names they can have, like probationary detective or guru at the end or something in between, whatever, there'll be some kind of reward system. And then a fire drill in this building one day, walked outside that door there, walked over there, and suddenly there are thousands of butterflies there, which was shocking to me. And so I asked somebody, where did these butterflies come from? And my colleague said, Canada. And I didn't say nonsense, but I didn't believe her. I came inside when the fire drill was over, I got on the internet, I looked up monarch butterflies, and they migrate from Canada to the US.